7. So you want to fast forward and watch number 7. So here's the answers. Take a quick minute, look these over, find the ones that you've missed, and then watch the video for the ones that you missed. Now guys, I'm going to go super fast, but that's okay. That's one of the advantages to having a video class. There's not many advantages, but one of them is you can pause the video and back it up all you want to. Okay, so I am going to go fast, so be ready to use the pause and rewind button a lot. Okay, number 1, find the inverse. Okay, now number 1, the first thing you do is you find the determinant. Okay, so multiply it up, change the sign, positive 20 multiplied down 21, add those together 41. There's your determinant. Next, you swap numbers and you change signs. Okay, so remember, it's these two numbers here that you're going to swap. So there, we swapped them. It's going to be these two numbers here that you change their signs. So negative 4 became positive, negative 5 became negative 5. Next, you flip the determinant and multiply the determinant through. So if you take 41, if you flip it, you get 1 over 41. And if you multiply it through the matrix like this, you will get this for your answer. Okay. Oh, a lot of you missed a lot of points on this one because there's 4 steps. Find the determinant, swap the signs, flip, and multiply through. And a lot of you did this. I don't know why. You just took the matrix and you changed those two. And you swap those two. And that was your answer. Well, guys, you left off 3 steps. That's 9 points. 9 points right there. Okay. Alright, moving on. Number 2. Alright, we're going to solve this equation, which means we have to get x by itself. Okay? So if we're going to x by itself, if you had an equation like this, the first thing you would do is you would bring the 5 over and make it a positive 5. So let's bring this over and make it positive, and it looks like this. Okay? Now, when you do that, on this left side over here, here's your equal sign. This is gone, and you're left with this here. So that's what you have. And if you add these two matrices together right here, you will get this right here. Okay, now next, you have to find the inverse of this. So here we go. Ready? How do you find the inverse? Well, first you find the determinant. Then you swap these two numbers right here. You change the signs of these two numbers here. Then you take 2 and you flip it. And then multiply it through. And there's your inverse. Now, what do you do with that inverse? Well, here's what you do. You put the inverse right here. And you multiply them together. And when you do that, they're going to cancel out. Okay? But here's where a lot of you messed up. Right here. You also multiplied this side by the inverse, which you're supposed to do. But when you did it, sorry for yawning, you put the inverse right here. And that's not right. The inverse goes right here. So you have to slide this over and put the inverse here. Now, guys, over here doesn't matter. Over here doesn't matter where you put the inverse. No, it does not. And I told you that in class. When you multiply a matrix times its inverse, it doesn't matter which order. They're going to cancel out no matter what. Okay, so you should have put the inverse right here, like that. And now these cancel out. Okay. And then you're left with x. And then here, we multiply these together. So row times column, 15, negative 4, that's 11. And then row times column, negative 3, positive 1, that's negative column, 10, negative 2, that's 8. And row times column, negative 2, positive 1 is, or sorry, negative 2, positive 1/2 is negative 1/2. And that's your answer. Now again, I know I'm going fast, but you can check, you can pause the video and back it up. Okay, find the determinant. Whoa, just like class, huh? Alright, so find the determinant. Okay, so I'm going to find the determinant of this matrix. So there's my matrix. Now remember, guys, you have to slide this over, pick up this column here, and copy it here. Okay, then you have to pick up this column and copy it here, and then multiply up, and you'll get negative. Oh, you have to change the sign, so you get positive on positive 9, change the sign to a negative 9, then multiply up here, and you get 0, multiply up here, and you get 0. Then we multiply down, and we do not change the sign, and you get positive 8. Then we multiply down again, and we get 0, and we multiply down again, and we get 0. Add up all 6 of these numbers, and you get negative 1. Okay, find the determinant of this one here. Multiply up 56, multiply down positive 48, negative 8. Okay, when you multiply a matrix times its inverse, you get out a certain matrix. What is it called? Identity matrix. When does a matrix not have an inverse? When its determinant is 0. Now number 7 was only worth one mistake. So if you missed it, just one mistake was taken off. But it says matrices and their inverses. Prove their inverses by using what? Sorry for yelling again. By using what? Matrix multiplication. In other words, I wanted you to multiply these two matrices together, and if they're truly matrices, you should get out the identity matrix. So let's see what happens. So here we go. Row times column, if 1. Row times column, negative 8 positive 8 gives you a 0. Row times column, 34 minus 34, that's 0. Row times column, negative 16 positive 17, that's 1. Okay, and that's it. Guys, I hope this has helped a little bit. If you have any questions at all, do not hesitate to comment.